This ball was launched 13 meters into the air. That's higher than a 4-story building. It had no rocket, no spring, no motor. It's a real Guinness World Record, the highest launch from something called a Galilean Cannon. Just a stack of ordinary balls. Here's the version you can try yourself. Balance a tennis ball on top of a basketball. Drop both together, from about waist height. Watch the tennis ball. It doesn't just bounce, it launches, visibly higher than the hand that dropped it. This setup has a real name. A Galilean Cannon, after Galileo. It's a classic demonstration of momentum conservation. There's even a toy version, the Astro Blaster, with a rod through the balls to keep everything perfectly lined up. This exact demo is one of MIT physicist Walter Lewin's most famous lectures. Millions of views, decades later. Lewin taught physics at MIT for over 40 years. Of everything he demonstrated, this exact bounce is still one of his most replayed clips. So why does this happen? Start simple. Both balls fall together, hitting the ground at the same speed. The basketball hits the floor first and bounces back upward at close to that same speed. Basketballs are built to be bouncy. Now the basketball moves up while the tennis ball still falls. From the basketball's point of view, the tennis ball closes in twice as fast as either ball was falling. Because the basketball is so much heavier, it barely notices the collision. It acts almost like a solid wall. The tennis ball bounces off that wall and comes away moving at roughly 3 times its original falling speed. A real basketball is about 600 grams. A real tennis ball is about 57 grams. Roughly 10 times lighter, not infinitely lighter. Height depends on speed squared. Triple the speed, and you get roughly 9 times the height, in the clean, ideal case. Real balls aren't perfectly bouncy, so real demonstrations fall a bit short of 9 times. But several times higher is real and repeatable. That 2-step story, basketball finishes bouncing, then hits the tennis ball, is the standard explanation. It's not exactly. But physicists who filmed this in slow motion found something the simple story misses. The basketball is often still squashed against the floor, not finished bouncing, at the exact moment the 2 balls touch each other. The 2 collisions overlap, instead of happening cleanly one after another. That produces a real, measurable effect. Sometimes the first bounce comes out lower than the simple model predicts, followed by a second, higher one. This is published, peer-reviewed physics, not a footnote. The clean version you just learned is a real approximation, not the whole story. Want to go further? Add a third, even lighter ball on top. A ping-pong ball. On the tennis ball. On the basketball. Each collision passes more of the impulse up the chain, and the effect compounds. There are even documented ideal mass ratios between the balls that squeeze out the maximum possible height. This isn't a fixed law of nature. It's a trick you can actually tune and engineer. Which brings us back to that 13-meter launch. Same trick, just scaled up and carefully tuned by people who understood exactly why it works. A stack of ordinary balls, some momentum, and one moment of overlap most explanations skip entirely. Grab a basketball and a tennis ball. Try it yourself, somewhere nothing breakable is nearby. Watch the aha happen in your own hands.